Hello, and welcome to episode 238 of Quarkus Insights. Today we've got Guillaume and Georgios with us, and we're going to be talking about Quarkus and Leyden, which I'm personally very excited to hear about because I've been sort of watching the conversation go by, and it looks really cool. But probably before we do that, we can talk about this week's news.
We just like to click the button.
I just like to click the button. Yeah, the only reason we do development in Quarkus is so that we have a stream of releases that allows me to click the news button. And although, in fact, we don't even need to do the releases because I've been promising 332 for about 4 weeks. So this is a bit like, the sort of the girl who cried wolf. 332 really has been released now, unlike last week when I said it had been released, and unlike the week before when I said it had been released, and unlike the week before when I said it had been released. But now we really do have 332 for Quarkus platform. And this is an important release because it will be the foundation for 333, which is our next LTS release. And so Guillaume would very much like everybody to try this if they are using the LTSs, because that early feedback helps us make the LTS better. Anything else on that, Guillaume?
No, cool. Definitely.
As I was saying it, I was having a panic whether I was going to get the version numbers right, because 333 is coming out at the end of this month, and 334 is also coming out at the end of this month.
Yes.
One is the LTS, one is scooping up all of this month's work.
Yep.
Other news is that next week there is no Quarkus Insights. A whole bunch of the Quarkus team are meeting for a face-to-face. And so we don't want to try and do a Quarkus Insights while we're also doing the face-to-face. So no Quarkus Insights. And also on team travel, you're at DevNexus, aren't you? When are you at DevNexus, Eric?
I leave tomorrow, so we'll be there Wednesday through Friday at DevNexus, and we for the first time we're doing a Quarkus and Leyden Chain for J community booth in the open source area of the conference. So hoping to talk to lots of people, find out what they're doing with AI and all that fun stuff. I've got a cool game too that I've written and have a prize for someone who finishes, who can do the game in the fastest amount of time. So it's going to be cool.
Excellent. So yeah, if you're at DevNexus, definitely stop by, say hello to Eric, see what else there is at the booth, say hello to the others. And with that, I think we can jump on to today's topic, which is Leyden. So what do we have to say about Leyden? What is Leyden, to start?
You can start, Georgios.
Sure. So like the way I see it, right? So this is the perspective of somebody who is like not an OpenJDK contributor, doesn't follow the mailing list like every day, like have very like lots of one-to-one conversations with people in the OpenJDK community, right? So this is like the perspective of somebody that like tracks a lot more than the average developer, but isn't an OpenJDK developer. Essentially, like most people in the Java community would agree that one of Java's shortcomings, at least in the last long time, is that programs written in Java usually start much slower than the equivalent program written in like Node, right? Or obviously like no comparison with Go or Rust or Zig and native stuff like that, right? So like OpenJDK obviously does a huge amount of work and it does it amazingly well, but there are always aspects that have been neglected for a long time, and like startup time for a long time. Now there were some people that like actually thought that no, this starts in like 5 milliseconds or whatever. But that's like complete, totally like fake benchmarks. Right? So in real life, like if you have a Java application that is like not like just a main class with nothing on the class path, it will take like, I don't know, 50, 100 milliseconds at the very, it's just close to impossible to go lower than that. But like for the longest time, most people said like, I don't really care. Like I only write server side stuff anyway. I don't care. It can take a while to start, right? But then like people started to see that, okay, other environments that can be equally as productive, right? So like nobody can claim that like it's easier to write something in Java than like Node.js, right? People that know Node.js as well as we know Java are equally as productive, right?
Unless you're doing financial calculations. Don't do financial calculations in JavaScript.
Well, I'm sure you have the proper libraries in Node that do that, right? If you know what you're doing, you can probably like just pull in the right npm package and it'll do it for you, right? So okay, like when I had like let's say like a JBoss Wildfly application or a Spring Boot app seconds to start, right? And somebody wrote like a Node application, sort of like 200 milliseconds, like you're like, okay, well, yeah, this isn't the best experience. And like I said, for the longest time in the Java community, but with the advent of GraalVM in like 2018, where you actually had for the first time a way to take a Java application, compile it to a binary that actually worked, like that wasn't toy applications and that was reproducible like every time. That people started to see that, oh wow, the power of Java, but you can like almost like Go or Rust like footprint, right? So I believe that really opened the eyes of people in the Java community, and they started to think, okay, well, wow, if you can go all the way there, well, maybe you can retain the let's say dynamicity of the JVM versus like what GraalVM does, which is totally closed and you can't like extend much. So that hopefully like you can retain sort of the dynamicity of the JVM, but get as much as that you can leverage as much of that like footprint improvement that ahead of time compilation will give you, right? So I believe like that really woke people up and started to focus minds on the problem of, okay, yeah, we can really do stuff about this. Like we're really good. We know what we're doing. Let's like put some good people on this and start working on it. Now that is my like really high level overview of how we got here. Let's say, right? And like the one answer to what Leyden is essentially it's a application in a training mode. Create a file and then when you rerun the same application with that file, then it just starts up much faster. And for the time being, it only consumes a little less memory, but in the future, consume a lot less memory, right? So that's the very short answer of what it is. Now, I can talk more about like the journey to get here, because like AOT didn't, the Leyden AOT stuff didn't come out of nowhere. There were, and there still are, more things in the JDK that were precursors to this. But I want to about this, like what I left out, what his perspective is.
I guess one thing before seems like very parallel to the story that Quarkus took from the very beginning, right? Like something that we said, hey, we should be able to do this.
Okay, so I should qualify, like none of the four of us were on the initial team that did Quarkus, but like from what we've heard, everybody knew that, you know what, Java does like way too much stuff when it starts up, and typical Java frameworks do way too much at startup. And yeah, you might bring classes, but when like every library is doing like class path scanning and reading a whole bunch of metadata, then all that adds up, right? And the Quarkus people, the initial team, figured that out, and they actually showed in practice. So yeah, you know what? When you take this away, then you can go much faster. You can start much faster.
Yeah, but it's true, Eric, that very much resonates with what we are doing in the Quarkus world since the beginning. So it sounds like it sounded like a good match for Quarkus, and yeah, we have some interesting stuff to share today about it. Maybe we could share the diagram that is showing what Leyden does. So basically what Georgios was saying about training is that, for instance, what you will do is start your application, run your integration tests, or run some load tests, or run whatever you want. But basically, make sure that this run that is recording the state is doing everything you want it to do for your application to be properly initialized. Once you have done that, you just stop the process for the training, and it will generate an AOT cache file. At the moment, it contains loaded and linked classes, some method profiling. So the method profiling is basically some information that can help the compiler to go faster to the best optimized state that you can have to handle the load that you apply to the application. So ideally, if you want method profiling to be accurate, you would try to push a load that is representative of what is going on with your application. Typically, if you push some load that always goes through the exact same path, but then when your application is running, it goes through a lot of different paths, it might not be as optimized as it should be, but still it's going to be better than if you didn't record anything. But yeah, the accuracy of the recording will help your application to start faster. So you end up with this AOT cache file, and then the only thing you have to do is to start your application by pointing it to this AOT cache file. So the JDK knows, oh, I have this cache file around and I can use it. So when you start your Quarkus application next, and actually any Java application, when loading classes, it will go first to the AOT cache file. If it's already there, then you don't have anything to do. That's fine. If it's not there, and that's the difference with GraalVM that Georgios was explaining about the closed world of GraalVM. GraalVM, if the class is not in the compiled application, then it cannot be loaded. In Leyden world, if it's not in the AOT cache file, it's not a problem. It will load the class from the jars. It's just going to be slower, but it will work. Then it will compile the classes as usual. That's where it can use method profiling. And at some point, the AOT cache file might contain the actual compilation state, which will end up make the warm-up faster. And once you have done that, you have your application started and warmed up. So that's where the Leyden helps. That's what it does. So what we actually went through during this journey is that Leyden, if you are in the JVM world, if you start your application in JVM and not in native, then Leyden, with relatively close to no additional work and no additional cost, but we will get back to it, makes your application start a lot faster, which is nice.
And so we're starting to get lots of questions through because people are excited. So the first question is, in Quarkus, will this affect production startup time or only dev mode?
So currently this is only production, and it's only if you opt into it. Now that's a good question. Like we should and we can and should explore like if we can make this available for dev mode as well.
So what's interesting is that what I was saying about the AOT cache file and the fact that if a class is missing, then it will be loaded, is that we could envision that we would ship properly initialized cache file with only the Quarkus classes, the base Quarkus classes. And then you would use this cache file for dev mode. That would make dev mode faster. So there are definitely things we could explore. But what we also have to have in mind is that there are some constraints with the AOT cache file. So at the moment, the cache file is relatively portable because it doesn't contain the compilation state. Once you include the compilation state in it, it's not going to be very portable because it will be dependent on the architecture and on the instructions that are available on the CPU. So, but if we don't go there, if we don't go up to the compilation state and we only keep the loaded and in classes method profiling, then bootstrapping a Quarkus cache that could be used for dev mode could make a lot of sense.
And I guess that kind of relates to Stupendous Fellow's next question, which is where is the AOT cache file stored, and does Maven Clean read it? Because it could be that we might want to change that and ship it.
Yeah, we'll show this in action, but essentially what happens is that currently, and this is the workflow we've defined and think makes sense, but this could change if people find this not good, is that the file is stored right next to the jar, the jar that you use to launch. And in Maven, yes, it's in the target directory, and Gradle's in build. So yes, if you do delete your jar that you produced, then yes, it would also delete the AOT file.
Cool, thanks.
Okay, so I have a couple points to mention before we move forward regarding to the stuff that Guillaume described earlier. So there's one interesting thing about GraalVM, right? So from Leyden, what is it? Start at closed world, right? And what Leyden does is it starts at open world and adds some closed stuff, but you can then open up if it's not there. What GraalVM is exploring is the opposite, right? That you do have a native binary, but they're exploring the ability to also ship a JIT compiler and a class loading architecture, right? Where you could have most binary, but for stuff that's not there, they're exploring how to then load it. So then you have this a convergence of sorts from two different angles, right? Trying to preserve the dynamicity of Java, but making it it's very interesting, where things will end up and but they're very exciting times.
Leyden.
Yeah, for both Leyden and GraalVM, right? Because they're both exploring this sort of space, so it's going to be very, very interesting. The other point I want to make is that Leyden didn't start out of a blank slate. The JDK, I think from version, I don't know, maybe some very old version, right? Had this notion of the app CDS file, right? So essentially it was a precursor to what Leyden does. If we go back to, if we recall Guillaume's diagram stored there, what it did, the first version was what it did was that it stored essentially some of the metadata themselves in a file, and you would never see this because that file was already shipped with your Java installation. So whenever you ran Java, the JVM under the hood would load this file. Now this progressively got better, and at some point, I remember a few years ago, when we bumped from Quarkus, Quarkus was requiring JVM 11, and then we said, okay, we'll go to 17. Or at some point when we were testing 11 versus 17, we saw that, oh, well, magically, like now the JVM is loading classes much faster, right? Like, what's going on? And I'm pretty sure, like, I don't have a flavor, but I'm pretty sure that what happened was that this AOT file, was called back then, started to contain a lot more data than it used to from between 11 and 17, which made the loading of JDK class. So that was already there. And also they had opened this application classes. So you could, if you knew what flags to run the application and train it, like run it with the flag and load, take it down, and then it would create this app CDS file and you would run it. And Quarkus had support for this, so we had added this, but it was like very experimental. It was just like kicking the tires to see what you could do. Some people showed interest in it, but like it wasn't very widely known. So people didn't think it was anything special, and the numbers weren't that great, right? Like you would go from maybe like 400 millisecond startup to like 300, something like that. So it was okay, but it was nowhere near as good as what we'll show now with Guillaume with the Leyden stuff, right? And at that point, we hadn't also looked into all the trade-offs that this file incurred, which Guillaume, I'm sure we'll talk about.
Yeah, maybe we can start showing some numbers before entering into the details. What we did, this is coming from an upcoming blog post that we are finalizing at the moment. So what we took is two applications. One is a very small one, so the smallest REST application you can have. You do Quarkus Create App, you have Vertex, Quarkus REST. So it's a full-featured REST application, but it has an hello world endpoint, and that's pretty much it. But still, it's the foundation of Quarkus REST application. Second application we took is a complete opposite. We took a very large REST CRUD application with 1K entities, 1K repositories, 1K services, 1K REST endpoints, 1K data mapper, and so on. We have 9,000 Java files in total in the application. So it's a large application. And we wanted to compare with these applications how it could, what Leyden would bring. And also we wanted to see how far we still were from a native executable, which is the current benchmark for when you want to start fast a Java application. The current benchmark is GraalVM on Graal native executables. So that's for the basics. So what's interesting is that for the default FastJar packaging, which is already quite fast compared to some other frameworks, we were in the ballpark of 400 milliseconds. And with Project Leyden and a whole bunch of optimization that we might talk about later, we were able to go down to 80 milliseconds, which is quite impressive for a Java application. But then it's still slower than when you go native. Native is still a lot faster. And when you go with the large REST application, so this is an Hibernate ORM application. We are, so again, very large model because you have 1K entities. Even if they are simple entities, it's still 1K entities. And so you end up starting in 3 seconds, which is not bad.
Given the size.
Yeah, given the size of the app. And with Project Leyden, we went to under 1 second. So that's three times faster. Then again, when going native, you are still a lot faster than with Project Leyden. But what is interesting, in my opinion, is that so you are getting closer to native, and this is basically for free because the training run is all well integrated into your Quarkus build. It doesn't require any specific knowledge, any complex stuff. You won't break anything. And you have this for basically free. So the basically free is important because it's not free. You will have to ship the AOT cache file that we were talking about. So one thing that makes a big difference between a JVM app and a native app is also the size of the container image. If you have a look at the metrics there for the container image, so for the default, so the smallest Quarkus REST app that we could have, it's already close to 500 megabytes for the JVM image. And with the IoT cache file, it's approximately 40 megabytes. You end up closer to 500 megabytes. So it makes the container image larger. And if you compare to the native executable, then it's between 2 and 3 times smaller. So that's also one of the things where the native executable shines. There are also attempts in the JVM world to improve on that. The thing is that for this image, you have to ship the entire JDK plus the entire JVM plus the application plus the cache file. So it adds up. And with G-Link and things like that, and some work that has been doing, we might be able to improve on that. I very much doubt we will be able to get as small as the native executable image, but I think we will improve and reduce the size in the coming months, probably years. And it's even more important for the large application because you end up with a 200 megabytes cache file. So you add 200 megabytes to your image.
Mm.
Can I ask a question? Maybe you're going to cover this is like not startup time, throughput. So I know like with native image, we always tell users, you sacrifice overall throughput to get native image. Is that the same here?
Yeah, we will come to that.
Okay.
So
sorry, Guillaume. I have another question too. Can you rewind a bit as well and explain what the difference is between the fast jar and the not fast, just a sort of an ordinary, old-fashioned jar?
So the fast jar is so back in the days of the early Quarkus. We were building what others are doing. We were building a runner jar that you had in target, you had a lib directory, and that was pretty much it. At some point, we discovered that just trying to figuring out if a file, a class, or a resource is present in the whole bunch of jars that you have was actually slow. So we ended up with some packaging that is called fast jar that does a lot of things to improve class loading. Typically, it keeps an index of the packages and where you can find them so that when you try to load a class, you actually know in which jar it's going to be, and you don't have to interrogate all the jars of the class path until you find it. Yeah. And so this is a promise of FastJar and why we ended up with this one. When most of these optimizations come from two factors, the layout we have on disk, which is carefully crafted to be optimized and also container friendly, and a class loader, a specific class loader that is very much optimized to to make class loading faster. Problem is that with Project Leyden, only classes that are loaded by the class loader from the JDK will be cached. So if you load a class with a custom class loader, it's not going to be cached. Thus, you basically lose one of the value of Project Leyden when you are using a custom class loader. So when we experimented at first with Georgios, we obviously used the default packaging, so fastjar, and we were like, oh, okay, it's twice faster. We were at 400 milliseconds. We went to 200 milliseconds. That's extremely nice. And then we figured out that a lot of class weren't loaded. Basically, everything that was, so we have this concept of parent first, and we load some very low-level classes from the JDK class loader in fastjar, but most of the classes are loaded from the custom class loader. And we figured out that, oh, okay, Project Leyden is not optimizing these classes. And when we went to the Project Leyden team, they said, oh, yes, that's expected because you are using a custom class loader. We don't support that. And so we tried with the legacy jar packaging that is still around in Quarkus, and the results were a lot better, meaning like 130 milliseconds, because so we were losing all the optimization of fastjar, but Project Leyden makes it so fast that it actually wasn't that important anymore. And that's how we ended up with a custom packaging. So this IoT jar is basically the same file layout as fastjar. So you will still have the Quarkus app directory and the Quarkus run jar and things like that. But it doesn't have some of the class loading magic that is in fastjar. It has a couple of other different optimizations to load resources, because we can optimize loading resources, which is important, for instance, for service files, for the service loader, your configuration files, things like that, your persistent XML, if you have one. And even if you don't have one, because Hibernate ORM has to figure out that you don't have one. So we have some optimizations for that, but we don't have the optimization of the class loading we have for fastjar. At some point, we hope that Project Leyden will support custom class loader under certain circumstances, and we will be able to get back all these optimizations we had in fastjar.
I guess that would help with dev mode as well. If we wanted to look at extending this functionality to dev mode, we use so many custom class loaders in dev mode, we'd be kind of stuck.
Exactly.
Yeah, and Stupendous Fellow has suggested a new naming scheme, and we did have pretty similar conversations internally when we realized that fastjar was not the fastest jar.
Yeah.
And we've got another sort of mechanics question as well from Christian. What if the app can run in different modes? So if it runs as, a command line in unattended mode, or it can also run in classical REST, would you need different kinds of AOT caches per app, or would you be able to share?
Well, okay, so theoretically, yes, you could have different AOT files, right? So you could start it with one profile, record the AOT file for that profile, and then keep it around and use the other one and do the same. But you don't have to. You could like start it in the command mode and you just record with that file and then always use that file with the rest. But that would mean that like the rest, the classes for the rest stack wouldn't be in the cache file at all. If you go the other way and say, okay, yeah, you know what, I'll use I'll cache all the classes from the REST profile, then that would mean that your cache file would have a bunch of classes that would never be used in the command line profile. So there are no inherent technical limitations here. It's just trade-offs as always.
But I guess one of the nice things about it is that it is just sort of a bit of a de-optimization in either direction, depending what you want to optimize.
That's what Guillaume mentioned earlier. That's very important for people to understand, right? That this, like the presence of a file, of the AOT file, should never prevent your application from prevent it's a bug, right? And we actually ran into a JDK bug that had been fixed in like 26 or something like that, and has yet to be backported over JDK 25. We just have to work around it in Quarkus. So yeah, there might be like small bugs, right? That they're small corner cases where like the presence of the file will cause a problem, but that shouldn't be the case. Like in almost all circumstances, the use of the AOT file should not prevent the application from functioning in the exact same way it does without the AOT file, which is, again, like Guillaume mentioned earlier, it's a big difference compared to what you have with crawl VM, right? Where it's totally closed world, and like there are certain things that you just can't do.
And when it doesn't work, it doesn't work.
It's a heck of a lot easier because, like, still there are things that you would have to do.
And one thing that is important regarding this question is that you cannot append to an existing cache file. So you cannot say, oh, I will train in this mode and then add to the existing cache file by training in the other mode. This is something that is not yet implemented. It might be in the future, but for now, you have one training run, one recording, and you cannot add more classes to an existing recording by doing another one. Yes, and so the important thing, and I think let's try to have a look at the graphics because they show exactly where we are. So if you have a look at the default and then Project Leyden, then native.
Native is on that graph, we promise.
Yeah, exactly. So native is still far ahead of what we get with Project Leyden. It's exactly the same for the startup time. It's the same for the container image size. It's also the same for the memory footprint. Okay, so you for now we don't beat native executables by far. So if you are in a case where, I mean, you are developing a Lambda, you need to scale from 0 to n extremely fast or whatever, then native executables are still very, very, very relevant. If you are in a constrained environment where you absolutely want to reduce the RSS usage, then it's the same. Native executables are extremely relevant. So what we wanted to make extremely clear is that JVM plus Project Leyden doesn't replace native. It adds something else in between JVM and native. And I think the point of what we try to do with Georgios, with this Leyden integration in Quarkus and making it simple, is that we think that except if the container image size is a problem for you, which might be the case, you should go with Leyden by default when you are using JVM. If you are a JVM user of Quarkus, try the Leyden thing because it's going to help with your startup time. If you are using native executables at the moment with Quarkus because you absolutely need everything that it brings, then stay with native executables. Leyden is not exactly doing the same thing. It's not in the same ballpark. It's different, and that's and that answers also the question you had about throughput, Eric. So when you go native, you don't have the JIT. We know that throughput is affected by that, and that's expected because that's You do with GraalVM, you do full AOT, you compile everything. So that's expected that you cannot be as optimized as a JIT will be. When you go with Leyden, you are in the JVM. So the only thing that changes is that you will go faster to a warmed up state with Leyden, but you are in the JVM world. So you have the JIT and you will have the exact same high throughput that you are used to with the JVM. Yeah.
It might be too.
I'm sorry, Holly, go ahead.
Yeah, it might be too early to answer this, but do we have a sense yet of what the cloud provider support is like for serverless? Because I know we've had some sort of counterintuitive situations with native where we say, okay, if you care about startup time, go with native. So serverless is a great use case for native, but then on some of the cloud providers, because of the internal architecture of serverless, it ends up being that actually the startup time, the overall system startup time is longer with native than it is with JVM. Do we have like a similar kind of unexpected, unpleasant surprise with AOT and
we haven't
gone that.
Yeah.
But the container image size, the fact that I was insisting on it is also because of that. When you are in some of the cloud providers, when you start a Lambda, the first thing they are doing, I think it's Azure doing that, they download the container. And it's not as fast as you would think. It takes time to actually download the container. So if you add 40 megabytes to the container to download, but then you start faster, it might just not be as good as you think. I don't know. You will have to test it.
Don't ask us.
Yeah, that's why I insisted on if the container image size is not a problem for you, because if it is, for whatever reason, then the fact that we add several dozens of megabytes might be counterproductive compared to the gain that you have with AOT. So that's also extremely important. We are not saying that it's going to solve all your problems in the same way we are not saying it's going to replace native. What we are saying is that there is a third option. It's relatively easy and extremely easy to experiment with it. So go ahead, try it, and it might bring some very interesting improvements to your startup times.
So I think with that too, Holly, you and I are going to add this to our benchmarking stuff that we've recently released too. So we'll be able to publish some numbers publicly about how this all works.
Yeah, that'll be great. Let's just think that you mentioned how extremely easy it is to use at this point. The reason he mentions that is because all you have to do is opt into one flag and make sure you have integration tests in the form of. So what we do under the hood is that we use the run of Quarkus integration test to actually masquerade as right. So we know that this isn't the perfect training run, right? But it contains, if your tests are actually like stressing the application in the way they should, the AOT file that will be generated will contain enough to actually make it very useful when you start up the application with the AOT file, right? So that's why Guillaume says it's very easy, right? You just need Quarkus integration test in one flag, and then like when you run your build, you'll get an AOT file. And in addition to that, Guillaume mentioned the container image. So the container image is also built, like if your target artifact of your Quarkus application will rebuild the container image with the AOT file in it, right, after the integration tests run. So that's what Guillaume means when he says this is extremely easy to use. And we've made it a lot easier because like you saw like AOT jar, fast jar, you don't have to care about that. Like just one option, and we make the defaults work under the hood, right?
So I think that's an important point to just like reiterate the at Quarkus integration test, because I've seen in the wild not a lot of people do that because it doesn't run during dev mode and all that stuff. It only runs when you do like Maven verify or Maven install or whatever.
Exactly.
So I think that's an important point for people to take. And mental note for myself, when we do this in the benchmarks week, I need to add a Quarkus integration test.
Yes, and
yes, exactly. So
yeah, you need to add an integration test, and you need to make sure that you are running them when not in native, because by default in the default generated project, integration tests are not run except if you go native. So what we do typically in the examples we were showing, we are doing -d skip its false to make sure that they are actually run when you.
Yeah. And that was for backwards compatibility, really, when we changed that. The first thing I always do when I generate a project from code.quarkus is get rid of that.
Yeah, we might want to rethink that default if we find that it's so useful for the AOT packaging.
Or maybe we add a flag that is also aware of that flag for AOT cache, and it does like an
well, it's a Maven thing, so you can't, right?
Oh yeah, you're right.
Well, okay, theoretically under the hood, you could probably set like system property, skip IT's false. Anyway, yeah, there might be some weird things to do, but yeah, like you said, this is for those who don't remember. Quarkus integration test wasn't the first kind of test we had. We used to have something called like native test or native image test. I don't remember exactly. That was very innovative, because what we did is like we wanted to use it because we wanted to make sure that when Quarkus built, like you did NVM package, that the native image you created, then you could actually start it, and like the REST stack or the gRPC stack or whatever stack you're using would work in native, right? The image has limitations. You absolutely have to test everything against it. So that's why the native image test existed. But then we're like, okay, no, this isn't native specific. This is like a integration test type thing. So we converted that to be able to like run containers, to be able to run like lambdas or whatever, right? So that's why it exists off by default, because that was the original setting.
Yeah, and if I remember correctly, I was the one who fought against Eric about enabling it by default. And one of the reasons is that it was relatively hard to get dev services working, so that because the integration tests, they are running in prod mode, so not in test mode. So your config is the one from production, which might not be suitable for testing, and it can make things a bit hard. The thing is that, if I remember correctly, we improved that a lot. And the integration with dev services and integration tests might now allow us to reconsider this, but we will have to check and make sure that.
Yeah, we can revisit. I mean, that was like 2 or 3 years ago at this point.
So, well, if I had the Quarkus integration test, wouldn't be a problem. Like if I had just like made the decision run as profile IT, right? Done. Yeah, this wouldn't be a problem. But oh well, I mean, we've made a lot of mistakes. And
hindsight is 20/20.
We own excuse me.
Yeah, and if I remember correctly, why also it runs in prod mode is that for the native executable, if you want to be absolutely correct, you have to rebuild the entire native executable if you use another profile, which might be problematic. So that's also why integration tests are using prod mode. We might have to revisit this, and that's also I wouldn't call it mistakes. It's just that it's your past choices. You made them because of some of the current state at that point, and yeah, things have changed. Maybe we will have to revisit things due to this work and some other work that is being done, but that's what makes things interesting.
Development would be much easier if the world never changed.
Yeah. And there's also something else. So our message is that if you are using Quarkus with a JVM, you should try this integration now with 332. And another message is that you should also have a look at your profiling. Because what we discovered by doing this work, and it's actually how it started, we actually started to experiment with Project Leyden to get rid of the class loading in our profiles, in our startup profiling, and make sure that we could have a fresh look at the profiling without class loading involved. And when you drop the class loading from the startup, you start to see a lot of things that you missed. And you didn't miss them because you were bad at your job or whatever. You missed them because it was impossible to see them until now. And we discovered a ton of things with Georgios when doing this work about, this actually, typically printing the startup time for Quarkus was taking a lot of time because we were initializing the big decimal class and initializing big decimal as a cost, but like a cost that is visible in a profile, just initializing the class. So we got rid of it. And obviously, if you use big decimal at some point, you have to pay that cost. But in this very case, we didn't need it. So why should all applications using Quarkus pay this cost? And we had some discoveries about the reflection compatibility that is done by Vertex and Netty to actually figure out if you support these dual threads. That is also slow, and we found out about a ton of other things, some allocations that we could avoid, and this work has just started because Georgios and I focused on basically Quarkus REST plus Vertex. I've been experimenting with Hibernate ORM, and we discovered a lot of other things. Julien Viette from the Vertex project, we had a discussion on Friday together, and we looked a bit more closely at the Vertex part, and we found a couple of other things that could be improved. I pretty much think that this work will bring a lot of improvements to the startup time. A lot of small improvements, but when you add all of them up, it's significant. And when you start in 80 milliseconds, then if you can do 5 improvements that each drop 1 millisecond, then you start in.
Let's focus on that a little more, right? When we started, like you said earlier, but it was it's like just Leyden and like the legacy jar or whatever it was, right? Just Leyden, the legacy jar got us from, let's say, 400 to 130, right? And then all the other optimizations Guillaume was talking about took us from 130 to 80, right? And but it's not only that. When we started this, well, basically Guillaume started it and I jumped on it as well. Like our target was like if we can get to 100, that's going to be amazing, right? That'll be super. But then okay, so Guillaume did like the AOT jar, which was like the biggest improvement in terms of like bring it down, I don't know, from like 130 to like maybe like 110 or something like that, right? Or 100, I don't know. But all the other little ones, right? Like getting rid of reflection in places that it should have been, or getting rid of like big decimal and like, I don't know, like time zone, some other JDK classes that like load a bunch of other stuff under the hood the first time you use them. All those little things, right, gave you another like 20 or 30 milliseconds, which is not insignificant in terms of
Georgios, I think we lost your audio.
Yeah, the suspense is killing me.
So animated and so into it, but nobody can hear what he's saying.
Yeah, and it was the cliffhanger. I guess he can still hear us.
He can hear us, but we can't hear him.
No, now he's looking confused.
Let's take guesses. We can place some bets here as to what he was talking about.
Yeah, while we wait for Georgios to come back,
Wait, no, he's miming it. Sorry, Guillaume.
Yeah, what is interesting is that for me, this work is, and everything we discovered is showing the path for all the ecosystem to move to better practices. Typically, using reflection to check if your virtual thread is something you shouldn't do. You should use a multi-release jar. Yes, it's a bit annoying. Yes, for the maintainer, it's less practical. Yes, it's harder to test, but the decisions you are making as a library or framework developer ends up impacting the whole ecosystem, meaning that every single application that is started and use your code is a bit slower because of the decision you made as a library or framework developer. So as a library or framework developer, your decisions matter because they impact the whole ecosystem, at least the whole ecosystem that is using your library or framework. So you should carefully weigh all the decisions you are making. And obviously, sometimes you will keep what you are doing because, yes, you will get 1 millisecond faster, but it's not worth it because you end up with crappy code or whatever. But in some cases, it's just work that shouldn't be done. And we should try to, as an ecosystem, in the Java ecosystem, we should try to make progress on this and improve on this because we are, that's something we figured out with Quarkus already when we started, but this is another level of optimization. We can improve. We have shown proof that it is possible to improve. It doesn't take that much time to improve, to be honest, because some of the improvements, they are like you do some profiling with a sync profiler and you are like, oh, this is bad. This is very bad. And this is not a judgment about past you, because past you didn't know about that, so he couldn't make the right decisions about that. But the present you and the future you, they should be aware of that, and they should profile also with Project Leyden, because it shows a new perspective and new things that you should improve. An example of that is so I will take one example, but please, people don't take it personally or judgment of the library itself, because we found examples everywhere in Quarkus, in a lot of libraries, so it's not a judgment at all. But in Hibernate ORM, for each annotation, for each Hibernate annotation, each GPA annotation, at startup, we are actually reading the annotation of the GPA annotation to find if it's inherited, what it's targeting, if it's a method, a class, and we gather this information at runtime. At each startup of each Hibernate ORM-based application pays this cost. Frankly, it's the easiest way to do it, and that's what I would have done if I had to code this 2 years ago. I would have done exactly the same, and even 1 month ago, I would have done exactly the same. But now, we know that reading annotations takes time. We know that doing it at each startup is a bad idea. We have seen it in the profile, so we are trying to see if we can improve that, and typically do it manually in the code. Have a test that checks that the manual information is in line with what we resolve when going through the annotation, to make sure that you haven't messed something up and hasn't forgotten something when you do a change. So we are verifying that things are fine, but we can drop all this work. So now will it improve things by like 400 milliseconds? No, obviously not. But if you add this to all the other small optimization that we were able to make, I'm pretty sure it will have an impact. I'm still working on that, and typically at some point I might figure out that it's a very bad idea. And maybe it's going to be a very bad idea, and I'll be like, oh, Guillaume, you shouldn't have talked about this example, you should have taken this other example. But still, I think it's a sign that we should have another look at what we are doing with Project Leyden enabled. And I mean us, but I also mean you, Quarkus users in your Java application. I think it's worth taking the time to do one profiling with Project Leyden and see how your application starts up and if there are things that you can improve, because I'm pretty sure you might find things that may surprise you. And this is not the title of a blog post. This is just something that we figured out.
Yeah, so true. And I think now is our chance to find out what Georgios was saying, except Georgios probably can't remember.
Well,
but you're looking very sharp.
Your video,
like so many minutes ago, it's like gone.
I don't remember. I have no idea where the sound cut off, right? But what I was saying is like the fact that we were able to get it to 78 milliseconds surprised us very much. Like we did not expect to be able to start an application that fast on a laptop. Well, a very good laptop, obviously, but no laptop nonetheless.
Yeah, and this is important. We had people pushing back about, oh yes, but when we push our application to a container, we don't have 16 cores. We are not on a powerful laptops, whatever. And this is true. And what we are saying is not that your application will start in 80 milliseconds. That's not our point, especially since your application won't be Quarkus REST Hello World. It won't be that. But what we are trying to say is that comparatively to not using Leyden, your application might start 3 times, 4 times faster, or maybe,
I'm actually pretty sure that, okay, fairly sure, let's say, that in a constrained environment, you would probably see better speed up versus like the totally unconstrained 16 core, 32 gigabyte RAM machine. I'm pretty sure like if you put it like you did like only 2 CPUs, you'll probably see a better startup time than what we see.
Now I'm chopping at the bit to get this into the benchmark suite.
Yeah. I'm really looking forward to what you folks are gonna post on this.
Yeah, and I think we also will have to have a look at some profiling for your application, the one you are using in the benchmark. I think we need to do some profiling on it, have a look at it, see if it shows something. I had a discussion with someone who is using, so for now, we have had a look at Quarkus REST, Hibernate OM, and Hibernate OM is really just a start. We have pushed one optimization, but not much there. And someone pushed me a profile with small I reactive messaging and Kafka. And it also showed some interesting stuff. Typically the fact that we are starting GMX while we actually don't really need it. It used to not be possible to disable it, but apparently nowadays it would be possible to disable it. So we should also have a look at that. And so basically any component that you assemble in your application we might be able to improve it and make things a bit better. And also,
we probably can, not might, probably. Like given the state of what most libraries do, like just very liberally, yeah, we like JMX liberal use everywhere. So yeah, we probably can do this, right? And there, like you said, there's a lot of stuff. Like you just started looking at messaging, but like no one has looked at like GraphQL. No one has looked at gRPC. There's all that stuff everywhere, right?
Yeah, so it's still very much in a process, and we are it's far from being done. And I think we will see improvements with this through all this year. But also, it's not magical. So if your application, when you start it, gets 2 million rows of Hibernate OS stuff and do crazy stuff with them, and this is not something that the Leyden work will optimize. Okay, what it will optimize is the class loading, and what we also did optimize is startup cost that is tied to Quarkus, the core of Quarkus, Vertex, the REST layer, and hopefully more in the future. But yeah, that's.
And that's probably a good point a good sort of message to leave it with. Thank you so much, Guillaume. Thank you so much, Georgios. Super, super interesting. I think probably lots of people, including Eric, are going to be rushing away to go try it and see what it does for their applications.
And I'm like, I got so much stuff to do this week and next week, but I want to push it all aside and jump on this.
Try it.
I'm sure Eric's going to open like 10 issues on this doesn't work, that doesn't work, that doesn't work.
Yeah.
Hey, we have to be reproducers, right?
Yeah. And we'll link to the blogs, and we'll link to the guide in the show notes. So if you do want to go try it, the instructions are there.
Yeah, and we are very, very much looking forward to any feedback, pushback, whatever. We are extremely interested in hearing what you.
We sometimes might not show it, but we love pushback.
Yeah. Yeah, so true. Cool. Thank you very much, everybody. And we won't see you next week, but we will see you in 2 weeks' time.
Just remember, in 2 weeks' time, we're in that weird time zone between the U.S. and Europe.
Yes.
So for those in Europe, it'll be no change. For those in North America, it'll be an hour later for like 3 weeks.
Yes, and I never quite know which way we anchor the invite. So if you're in Europe and it changed time, it's because we got it wrong or we guessed wrong which way.
And we always get it wrong. We always say we're going to fix it, and we never do, because it's one of those hard things.
Yeah, 3/4 of the things are anchored to one, and 1/4 of the things are anchored to another, and we've never managed to get it all consistent. Time zones are the third hardest problem after naming things. Cool. See you all.
Thank you. Bye.
Bye.
Bye-bye.